Hey everyone, in this session let's understand how to handle exceptions in Python. Exception handling is a technique to handle runtime errors gracefully. What is runtime error? Errors in Python code are of two different types, syntax error and runtime error. If there is any syntactical error in your Python code, that can be easily handled before running the program. Your Python compiler will show you what are the errors occurred in your Python code, and you can manually easily fix them up before running the program. However, runtime error is the more severe one. Why? Because this kind of errors you cannot understand unless your program is running. And if your program is running and some runtime error occurs, your program will stop abruptly. In order to handle this issue gracefully, we use exception handling in Python. There are few keywords which are important to handle exceptions in Python code. Try, except, else and finally are four keywords which are important to handle exceptions in Python. The Python code which are error prone, we will write them within try block. If there is any error within try block, except block will execute, and within except block we will write the code to handle the error gracefully. We don't want abrupt termination of the program. In order to handle that, we will write all the necessary code in except block. After a successful run of try block, if you want to execute a code segment, you can write them within else block. There is finally block as well, which is also optional, and based on your use case you may or may not use finally block. Remember, finally block will execute always irrespective of the errors within try block. Let's summarize this. The error prone code we will write within try block. If there is any error, we will handle them within except block. If there is no error, then you can include else block in your code and write the code segment within else block. If you want, you can write finally block. Remember, finally block will execute always irrespective of there is any error within try block. Let's understand this flow with an example. Here we are taking dividend and divisor from users and performing a division operation. Assuming that this division operation is error prone, I have written it within try block. If there is any error, except block will execute because this red arrow will be followed. If there is no error within try block, green arrow will be followed and the control will go to the else block to execute the code segment. And at the end, the finally block will execute irrespective of code has any runtime error or not. Let's take a positive example and a negative example to understand this code in detail. User is passing 5 as dividend and 2 as divisor. What will happen? 5 by 2 will be performed and finally 2.5 will be within a result variable and we are printing the result. After executing these two lines, it will go to the else part because there is no runtime error occurred so far. In this case, I have just given you an example by writing this print statement. However, based on your use case, you can write a code segment within else block. And finally, block will execute, it will print program completed. Let's take a negative example. We are passing 5 as dividend and 0 as divisor. What will happen? 5 by 0 operation will be performed, and this operation is an invalid operation as per Python program. That's the reason it will have a runtime error. If there is any runtime error, it will not execute the next statement, rather it will jump to the except block. In this case, we have written a simple print statement, exception occurred. But in real Python programming, you can write a code segment to handle this error well. Now let's understand what is this exception. This exception is a parent class of all runtime errors in Python. To understand it in detail, let's understand exception hierarchy. In Python, base exception is a category under which all exception classes will come. In our next session, we will understand what is Python classes. For now, you understand that base exception is a category under which all other exceptions or runtime errors will come. Under base exception, there is one more category called exception. Exception is a parent class or parent category of all other runtime errors. Under exception category, there is arithmetic error, operating system error, name error, type error, value error, and few more other types of errors. You can go through the official document of Python to understand each one of them well. Remember, these all are built-in errors present in Python. That means Python is giving you a out-of-the-box solution to handle all these kind of runtime errors. Apart from built-in errors, apart from built-in exceptions, a programmer can create custom exception. In this example, we will see what is the use of custom exception and how to create a custom exception in Python program. The problem statement is, if the age of a person is less than 18, then we will raise an invalid age exception error. If the age is more than 18, then the person is eligible to vote. What we are doing here, we are taking age from user, and within try block we are checking what is the value of age. Is it less than 18 or not? If the age is less than 18, then we want to forcefully create an exception, which is invalid age exception. Raise is a keyword through which forcefully we can create an exception. If there is any exception within try block, we have understood that it will directly go to the except block without executing other statements within try block. And except is a block in which we will handle the error. If the age is less than 18, we are raising an exception, and that exception we are handling within except block. In except block, we are writing exception invalid age. I have written a simple print statement, but based on your use case, you can write hundreds of lines here to handle the exception. Now, whenever a programmer will create a custom exception class, they have to define it. In the case of built-in exceptions, the classes has been created by the Python developer themselves. However, if we are creating any custom exception class, we have to define it, and that is the reason we have defined it here. I will not go to the details of how to create class and what is the meaning of class in Python. In our next session, we will learn what is a class in Python. To summarize this session, basically exception handling is a process to handle the runtime errors gracefully. Let's go to the PyCharm IDE now to understand exception handling in detail with some examples. In this source code, we will understand how to write Python code to handle runtime errors or exceptions. Here, as you can see, there are two variables, dividend and divisor. Within try block, basically we are performing a division operation here, and this division operation can raise some runtime error. We will see that in action. If there is any error during runtime, except block will execute, and in this except block you can handle the runtime error gracefully. For simplicity, I have written just a print statement that error occurred, so that user can clearly understand that there is some runtime error happened because of the values they have provided. Else part will execute if there is no error within try block. Except block will execute if there is an error in the try block. Finally is the block which will execute irrespective of errors within try block. Let's run this program. It's asking for dividend, we can put 5. Let's put divisor as 2. You can see there is no error, and that's the reason except block did not execute. However, else block executed successfully. Finally block will execute irrespective of the errors within try block. Now let's rerun this program again. This time I will provide 5 as dividend and 0 as divisor. If you see here, basically the operation will be performed like this: 5 divides 0. As per programming language, we cannot perform this operation. Divide by 0 is not possible in Python program, and that's the reason there will be runtime error within try block. If there is any runtime error within try block, except block will execute. That's the reason you can see exception occurred. Else block did not execute, as we have understood in our previous discussion. Else block will only execute if there is no error within try block. Finally block will execute even if there is an error within try block, and that is why you can see program ended successfully. Let's understand how can we create a custom exception in Python. We will understand this part, creating a class for custom exception, later. First understand how can we use it in a Python program. Here we are taking age as input and we are checking if the age is less than 18 years or not. If it is, then it will raise invalid age exception. This invalid age exception is not a built-in exception class in Python. As a programmer, I have created this class to use it in my use case. If the condition age less than 18 is true, then the person is not eligible for vote and invalid age exception will be raised. Remember, raise a keyword which forcefully creates an exception or a runtime error. So if the condition is true, then we are forcefully creating an exception. Otherwise, we are printing eligible for vote. If we provide the age as 17, then if condition will be true, then we will be creating an runtime error or exception called invalid age exception. If the age is 18 or more, then else part will execute and it will print eligible for vote. In case we are raising this exception, what will happen? It will not execute all the other part. It will directly jump to the except block. And in except block, we are handling the exception gracefully by saying that there is an exception because the age is invalid for vote. Now, as this invalid age exception is not a built-in class in Python, we have to create that class here in our code. That is what we are doing here. Remember, as per the hierarchy, exception class is the parent class of all the other exceptions. That's the reason, even if as a programmer we are creating an exception class, that has to be a subclass of exception class. In our next session, we will understand class and object of Python in detail. But for now, you understand that if we want to create a custom exception, we have to create that class under exception parent class. Let's run this program to validate our understanding. When we are providing the age as 17, we are raising a exception manually and that will be handled within except block, and you can see exception invalid age has been printed here. Rerun the program with the age as 19. There will be no exception raised, only else part will be executed and eligible for vote will be printed in the console. Let's take this example, and in this example I have disabled try and except blocks here just to understand that what runtime error we are getting in this statement. If we run this program and provide 5 and 0, we get 0 division error because we cannot divide any number by 0. Let's rerun this program again. This time I am putting 5 and a. Instead of any integer, we are putting some character. User can provide any value, right? And that's the reason there can be runtime errors. As a programmer, we have to handle it wisely. Let's run this. You can see there is value error this time the error type is different. So that means the same line can throw two different errors at runtime. Let's run this program one more time and pass 0. It is showing me exception occurred. In the second case, when we are passing 5 and a instead of an integer, it will again show exception occurred. Now for a user, it's very difficult to understand what is the meaning of this exception occurred. It is very difficult for a user to understand what mistake he or she has done. That's the reason we can have multiple except blocks and pinpoint the error so that we can provide a fruitful message to the user and user can understand his or her mistake. Here in this case, if you see, I have added multiple except block, one for value error, one for zero division error and one for exception class, which is for rest of the different errors if we get during runtime. And now run the program again. This time if we pass 5 and 0, it's explicitly telling that divisor cannot be 0. If we rerun this program again, pass 5 and a, it will give you correct information that value entered is not an integer. By seeing this specific error message, a user can clearly understand what is his or her mistake and in next run they can fix it. That is the main purpose of having multiple except. If this line is raising value error or this line is raising zero division error, both are subclass of exception. That's the reason if we put this except block before the other except blocks, then always this will be true and it will print only this and all the other except block will not execute. Even though there is a value error, it will not match with this because before value error it will match with this, because a value error is also a kind of exception. A zero division error is also a kind of exception. That's the reason it will never execute these blocks even though it is a value error or a zero division error. That's the reason we always have to handle parent exceptions at the last. Thanks for watching this video.